Okay, yeah, I got the window open. It's actually a nice day out now. So if you get some extra background noise, that's probably what it is. That or my dog is going to bark at me. So here we go. This is just kind of like an introduction to conversions and how to work with them as far as proportions go. If you've seen other videos that work with them, I'm going to call it on a more scientific basis. Some will refer to it as dimensional analysis. It's basically converting from one type of measurement to another of the same denominant. So if you're measuring length, you're still going to be measuring length, just in a different unit. I would encourage you to use that for some of the more complicated problems. But if you are hard stuck in proportions, it'll work. Trust me, it'll work. It'll be okay. Just might need a few more spots or a few more thoughts. I'm still getting used to this new program. This is a thing called Drawboard, and so I'm trying to do this in PDF format, that sort of thing, so I can save it. First rule, by the way, you want to make sure that your units match. So when you set up the proportion, you want the same units on top, same units on the bottom. It's just, there are other ways to do it. Just do it that way. It's easier. For compound units, miles per hour, that sort of thing, I highly recommend that if you're going to use the proportion method, you do so separately. So if, for instance, I was going to convert, let's say 15, wow, that does not show up. Let's take white. Let's just do that for now. 15 miles per hour, then I would, and I wanted to go to, say, feet per second, which is FPS. Unless you're a gamer that is first-person shooter, but hey, we can't all be gamers. Then I'm going to start with the 15 miles. So I'll say 15 miles is how many feet? And there is 1 mile in 5280 feet. And this is where you cross multiply. So let's see, we can pick a lighter blue color here. And then we get teal. We cross multiply. I would ignore the units at this point. If the units match top and bottom, you will get the right unit. I'd probably let it go. So this is going to be 1x, or just x, is equal to 15 times 5280. I gotta get a calculator here. The units will cancel out in the division, but if you carry them through, it might be quite confusing. So 15 times 5280, 79.2. So this is going to be 79,200. And then if I were to go to, that's going to be that's too much. Where's I need brighter thing. There we go. Apparently it's a color of red. And then I'm going to change hours to seconds. And so I have 1 hour, because the 15 I kept with the miles, so I have 1 hour per how many seconds? Ooh, I don't know. If you happen to know, great. If you don't, well, I can put it in minutes. So in how many minutes? If you can do this in your head, just go ahead and do it in your head. And it's 1 hour per 60 minutes. So another way that you can think about this is that you can go straight across. Because they're the same on top, they must be the same on the bottom. So now I'm at 60 minutes, but I want to know, well, how many seconds is that? Well, there's 1 minute in 60 seconds. Notice how I'm keeping them in the same location. So then we're going to go ahead and we're going to cross multiply. We'll use teal. And this is going to give us, again, 1 times x is just going to be x is equal to 60 times 60 is 360. Or, I'm sorry, 3600. It's 36 and 2 zeros. So now I can't just do this in proportions very easily. I first convert the miles to feet, so this is going to be feet. And then I convert the second, or the hour, into seconds. Then what I need to do is I need to read through this and understand that, well, to find that answer, I am going to need to divide. So this is going to give me 79200 divided by 3600. just because I'm lazy, I'm going to do this. It's basically dividing top and bottom by 100. So I have 792 divided by 36. This is going to give me 22. So this is now 22 feet per second. And that's how you do a compound unit. It's obviously not a very easy process, and the chain is a little bit easier to work with in this circumstance. But if you're uncomfortable with it, this will get you through. We actually encountered number 3 as we were going through this. Maybe switch to a pink. Yeah, let's go to a... let's not do that. Let's go to an orange, maybe? Yeah, let's do an orange. We can't go from one measurement. How about one measurement to the other? You need to set up a proportion for each step along the way. Well, we went from hours to minutes, and then from minutes to seconds. So we had to do it in 2 separate steps. Each time we had to set up a proportion. Again, this is something that is, in a sense, taken care of in the chain all at once. But you can do it. So those are my just the 3 quick rules on working with proportions. And then here's a couple of examples. So let's start in white and we'll go from there. Example 1, convert 15 tablespoons to cups. Okay, so not everybody knows this. However, I sometimes do some baking, sometimes do some cooking, and I'm a stickler for remembering stuff with numbers because it was just ingrained in my skull. So I need 15 tablespoons of something because I'm making a big batch. Well, it only gives me tablespoons. It's really annoying to work with tablespoons. So I want to know how many cups is that going to be. So when I set up my proportion, I have to make sure that cups are on the bottom and tablespoons are on top. I happen to know that there are 3 tablespoons in a quarter cup. Even though you have a fractional amount in the denominator, the cups still match. The unit of measurement is still the same. So now I need to cross multiply. This may or may not be nice, so bear with me. Again, ignoring the units, 3 times x is just going to give me 3x is equal to 15 times 1/4. In this instance, I would not use decimals, but you could. The reason I wouldn't use decimals is because most of the time, cups aren't given in decimals. They're given as fractions. So we're just going to go ahead and use a fraction here. 15 times 1/4 is just 15 times 1 divided by 4, which is 15 quarters. Now, I would go ahead and I would divide both sides by 3. When I do this, I'm going to recognize that 3 is really 3 over 1. So I get x is equal to. This is going to force me to invert and multiply. So 1/3. Now I can cross cancel here. Some people will notice cross cancel, some people just know as reduction. I can reduce before I multiply. So if I divide both 3 and 15 by 3, I get 5 here and a 1 here. So this is going to give me 5 times 1 is 5, 4 times 1 is 4, and so I get 5 quarters. How do you want to measure that out? It's up to you. If this is, for instance, tablespoons of sugar, and you're making a big batch of something that also calls for flour, I would probably use a 1 cup and a 1/4 cup just simply because they're both dry ingredients. But if I have a choice and I've already dirtied the cup, rather than wash it and do it, I'd probably just use the 1/4 cup 5 times. Again, it's up to you. I'm just not doing the I'm not measuring out 15 tablespoons. That's gross. As you get better at this, you'll be able to convert it more easily. So in the kitchen, I would probably convert that and just use cups, but I know a lot of people just start 1, 2, 3 tablespoons. That's fine. Both get it done. A more complicated problem, and so if you want to stop the video here because you kind of got the idea, go right ahead. This is specific to a project that I give my students, and so I kind of want to demonstrate how I would go about doing a very similar problem to theirs. Suppose you want to estimate the cost of constructing a road gravel driveway. This is real because we actually did this to our house. And I want to know. It's sold at $20 a ton and has a density of about 200 pounds per cubic foot. This is not necessarily true in the real world, but I had to make something that wasn't the same numbers. For a driveway 50 foot long, you can't see that, 50 foot long, 6 inches thick, and 15 feet wide, how much will it cost to construct the driveway? All right, so I have to convert 200 pounds to tons. I also have to have some sort of cubic foot measurement. Cubic foot. That means that my inches, so if I imagine this particular driveway, keep in mind the picture is just as a guide, it's not true to scale. If I'm looking at the end of the driveway, it's going to kind of look like that. It's going to look like a rectangle where that's all road gravel. And then the driveway is going to go back 50 feet. So I have this shape. It's a solid, so it's a rectangular solid. Now, cubic feet is the amount of stuff that I hold in my hand. It's a volume. To find the volume of a rectangular solid, you take the length times the width times the height. So if I mark those down here, my length was 50 feet, my width was 15 feet, and my height was 6 inches. I can't have 6 inches. It's got to all be the same. So I'm going to go ahead, and there are ways to get around this for those of you who are like, but I use linear board feet. I know, it's a trick. I don't do that here. Anyway, we need to convert 6 inches. 6 inches equals how many feet? If you can do the conversion right off the top of your head, fantastic. If not, there are ways of doing it. First of all, I'm going to do this. I'm going to say I need feet, so I'm going to put feet on top just to make it easier on myself. Some sort of feet in 6 inches is equal to, in 1 foot, there are 12 inches. If you already see the answer, great. If not, just follow along. So I'm going to cross multiply. That's going to give me 12x is equal to 6. Divide both sides by 12. And I get x is equal to 6/12, which reduces to 1/2. So it's a half a foot. So I can just mark that here as the height is 1/2 feet. Now that I'm all in feet, I can find cubic feet by using the volume. Plugging that stuff in, our volume is equal to 50, and I know I'm going to get a lot of feedback, like, you need your feet. It's going to be cubic feet. We'll do that as a separate calculation. 50 times 1/2 times 15. That's going to give me 25 times 15. Well, 15 quarters is really what we're looking at. It's just shy of $4. So this is going to be $3.75. So it's 375 cubic feet. Oh my Lord, I ran out of space. I'll back that up. We're going to put it to save space, feet cubed. Same thing. So now I know how many cubic feet that I have. I need to convert 200 pounds to tons. So when I do that, I have 200 pounds to tons, so this is going to be 200. Yeah, I'll just do it this way. It's just easier. 200 pounds is how many tons? And in the English, well, I say the English, in the American system, since the English don't use it anymore, it is 2,000 pounds per ton. Now, I've heard that there are 20 to 40 pounds in a long ton. I don't believe that that's necessarily accurate, because I think the long ton is referring to the metric ton, and it's 2,209 is the closest to the nearest pounds. But this is going to be 1 ton. So cross multiply. This is going to give me 200 is equal to 2,000 times x. I divide both sides by 2,000 to solve for x. You can confirm it. I'm just going to go ahead and use the decimal in this case because I think it's going to be a little easier to work with, but 0.1 is equal to x. All right, so this is my weight. So this is 200 pounds. Okay, so we are told that we get 200 pounds, 200 pounds per cubic foot. Wow, okay, we are not scrolling for some reason. There we go. 200 pounds per cubic foot. So I have 200 pounds, which is going to be 0.1 tons per cubic feet, per 1 cubic foot, equals how many tons in 375 cubic feet? I need to know how many tons because that's what I'm buying it by. All right, so cross multiply. That's going to give us x is equal to, and 375 times 0.1 is 37.5. So this is going to be 37.5 tons. Now that I have the amount of tons, I have the cost per ton, which was 20 bucks. Come on thing. It's so angry right now. There, we'll just use our fingers, I guess. $20 a ton, so $20 times 37.5 tons gives me, well, I don't know, that seems awful large. Well, twice that is going to give me 75, and so this is, 75 and a 0 is 750 bucks. Let's confirm that because I'm lazy. I'm feeling off today, times 37.5. Yep, 750 bucks. So it's going to cost me $750 to put that in with road gravel. Now this price probably does not include spreading it out, that sort of thing. So take that as a grain of salt, but it just shows you that just knowing a little bit about conversions, that sort of thing, can actually allow you to solve a fairly complex problem, and that way you can check the math of the person that you're hoping is doing it the right way. It always helps to check each other because somebody's going to do it wrong, I guarantee it. That's it. That's how you use conversions to solve a problem that's very similar to the one that you're going to see on your project. Glad I could help.